Good afternoon, everyone. Welcome to the fourth day session on AICT-sponsored SGTP program on design of experiments in engineering. Today, we have the afternoon session, Dr. Vijay Kumar, who is assistant professor for mechanical engineering from NIT Warangal. And here is a small introduction about Dr. Vijay Kumar. He has done his PhD in Industrial and Systems Engineering from IIT Kharagpur, MTech from Industrial Engineering and NIT Calicut, and his research interests include intelligent manufacturing systems, cyber-physical systems, sustainable supply chain, healthcare systems, and he has published more than 85 publications, which includes journals like International Journal of Production Research, Computers and Industrial Engineering, International Journal of Computer Integrated Manufacturing, etc. And he has received many awards, including early career research grant from DST for his research work in telefacturing systems. And he's a member of Institute of Industrial and Systems Engineering, Institute of Engineering India, lifetime member of International Association of Engineering, USA, and also acting of a technical committee member and reviewer for various international journals and conferences. I personally know him from back of our MTech days, where I was pursuing my manufacturing, but he was doing his industrial engineering, and from there he has gone to IIT Kharagpur, then worked as a VIT, and then it's been like 2 years since he's working from NIT Warangal as an assistant professor. So we are very glad to have you here, and thank you for accepting this invitation and to present your topic. And since he's from industrial engineering background, he has modeled many what you call design of experiments, as well as this Topsys models and the Taguchi models and all for his projects. And that's the reason why we brought him here. And I hope sir will explain us on several case studies. And I think that will help in understanding in deeper sense of design of experiments. Thank you, Dr. Vijay, once again for accepting this invitation, and over to you. I request you to start the session.
Thank you, Dr. Varun. Thank you, Dr. Varun, for reading my profile. I am little, hesitate to say Dr. Varun because he is one of my good friend. And that is why I can call you Varun if you don't mind.
Sure. It's more formal to call you Dr. Vijay and Dr. Varun. Yeah.
Yes. It's my pleasure, and thank you so much for calling me for this wonderful program. And I saw the session. The sessions were nicely organized, starting from introduction and how you were lining this DOE analysis towards up to today class. It was wonderful, and I hope I will try my best to give my particular session, and I'll try to inline my concept towards the DOE now, because let me talk to the participants now. Thank you so much, and I would like to
you may share.
Share the PPT, please. And most of the participants are UG, PG, as well as PhD scholars, or
scholars, faculty members.
It's also faculty members.
UG are not included. PG, PhD scholars, and faculty members from various disciplines. Most of them are mechanical, but during registration, we also received from other branches as well, civil, chemical. I think they do need design of experiments from other.
Yes. Okay. Could you please share the PPT? I already shared it.
No, it's not displayed.
Okay. I'm sharing now.
Okay. Yeah, now it's fine.
Okay.
Screen is visible. Right.
Yeah, I hope my presentation is visible, and I hope my voice is also loud and clear.
Yes, sir.
Great. So good afternoon, everyone. And I just got to know that you are the master's, PhD, as well as Some of you are the faculty members here of various disciplines. As you are presented here, my topic also, moreover, it's look like interdisciplinary subject. It is not totally inclined towards the mechanical engineering platform, as I done my PhD and my research is towards the interdisciplinary area that is called industrial and systems engineering. The current topic chosen is also more can be used in more interdisciplinary subjects. You will understand at the end of the topic. I would like to bring this concept that could be useful for different disciplines. And first of all, why I have chosen this topic, because the session itself is the short-term training program itself is a DOE analysis. When you see TOPSIS, it comes out of blue, I hope, for most of you, because it is not exactly related to the DOE. But why we have chosen and why we brought this concept here? It is not exactly related to the DOE analysis, but it could be integrated to the DOE analysis. So after completion of this particular topic, you will understand how you could incorporate this TOPSIS, or TOPSIS, we are calling it as the MCDM approach, multi-criteria decision-making approach. Out of that, this is one such technique. Out of various techniques, this is one such technique. How this can be integrated towards DOE, so that the solutions what you are getting after doing the DOE analysis could be improvised or make the better solutions by integration approach. That also you can see after the end of the session. And my session could be looking like this. I will introduce this particular MCDM that is called multi-criteria decision-making approach, different approaches. And out of it, I will bring the concept of TOPSIS, and I will detail the TOPSIS with the help of some small numerical examples. Could be manufacturing perspective or this or in general, because your interdisciplinary students are available, different participants are available here. I will take the general example, and then I will move towards the manufacturing related problem, and then I will take some complicated cases which we already published recently. So those use cases I will take to explain about these TOPSIS or MCDM approaches, and then I will take queries with respect. That is the idea of my session now. So first, what is this TOPSIS? All that it comes from the umbrella of MCDM. The word MCDM means it's called multi-criteria decision-making analysis. Up to now, you might be see many sessions with respect to gray relation analysis. You must be see something about Taguchi or some other DOE analysis. Could you examine when you were all the problems are not in the nature of quantitative? Like every analysis you cannot do by experimentation. Sometimes you have to take the decision makers' criteria. Maybe some analysis with respect to the qualitative analysis rather than the quantitative analysis. Then how you will identify those kind of the values, what you use in Taguchi, that is L27 or L32 or some kind of tables, you will make it right. Inside those values, you are generating by preferences, or those preferences, if you are having a experimentation called quantitative analysis, you do some experiment and you will generate the value. That can be nicely fitted in the tables and you can be generating the results, or you do experimentation according to the experimental setup. But if your analysis is with respect to the qualitative in nature, then the real difficulty comes. So for those kind of problems, how to handle, how to solve, the other kind of methodology is there that is called MCDM approach, multi-criteria decision-making approach. You will see in detail. about while we are solving the problem, you will understand much better what I'm talking right now. So that is one thing. The another way why we some CDM approach are using is called when your problem nature is in conflictive nature. What is the meaning of conflictive nature is, for example, if I ask some of you to purchase a car, maybe his or her priority could be like this. Maybe somebody is looking for a lesser price, right? And somebody looking for aesthetically beautiful. Price is not a concern for the other one. Maybe some other perspective might be, no, the cost should be less and the car should be aesthetically beautiful. So each and every individual is having their own criteria and their own preferences, right? And own perspectives. So how to meet a single criteria, for example, total cost. The cost is a criteria, means yes, I can fulfill his willingness very quickly. I just choose the car which is lower cost. There is no complicacy in this. And if somebody is saying that aesthetically beautiful, and I don't have any conflict again, so I can choose a car which is aesthetically beautiful than the other ones. But the real complicacy will come when somebody was asking me to choose a car with a low cost, aesthetically beautiful, and let me add some more points here. The quality should be good. All these different criterias. So if to choosing a car with satisfying of all these particular parameters which are conflicting, the meaning of conflicting here is one should be minimization because the cost is should be minimal, and the quality is entirely different. It is maximum, and aesthetically beautiful. Aestheticity should be measured in not in terms of parameters like quantitative. It is a qualitative parameter, right? And if I keep on adding these parameters, the problem complexity may be very high. So how you will choose this kind of thing? So for that, the techniques such as MCDM, multi-criteria decision-making analysis, will be helpful. Not only that, if you want to find out the optimal solution out of it, this particular MCDM approaches will help us. So let me read a definition because the definition is a definition, I have to read as a definition. It is given by Stanley Giants at 1979. According to him, so it consists of constructing a global preference relation for a set of alternatives evaluated using several criteria. So I hope this particular definition is giving some, so it is a little fuzzy. Let me read the other definition so that it will give some meaning, some sense. The other way to read this definition is selection of the best actions from a set of alternatives, each of which is evaluated against multiple and conflicting criteria. Now, from this definition, I show you what is called conflicting criteria. The example what I was quoted just now, a car example, it's actually a conflicting criteria. And evaluating of a multiple, the multiple meaning of multiple means that different parameters. Evaluating of those multiple parameters will lead towards a conflicting criteria, and you have to take the best out of it. That is called selection of the best actions from a set of those alternatives. So how to choose that? And you cannot choose that one randomly. If you choose a random, and you may lose a best solution out of it. So this generally happens in the multi-criteria problems. If you want to solve problems such as multi-objective nature, according to the operations research, we may solve the problems with respect to single objective functions and the single objective functions most often. The problems which are maximization in nature and the problems are minimization in nature, right? And of course, various algorithms which are available for us, like the generalized algorithms or the criteria, that is soft computing techniques, etc. All these are available in front of us to solve the problems. When we are saying something like conflicting criteria, means it is a case of multi-objective in nature. When I said the multi-objective in nature, the two or three objectives simultaneously you have to solve it. When you will choose a route called artificial intelligence, machine learning, or soft computing techniques, or the evolutionary algorithms, all these is when you have something called quantitative in nature, and when you develop a mathematical model out of it, subjected to objectives and the constraints, then of course those route can be chosen. But as I said, if your objectives is with respect to multi-objective, and not only that, if it is a qualitative nature, then this MCDM approach could be chosen. So I hope up to here, why I am taken this MCDM is understood. So here, if you choose MCDM, there are various methods are available, right from some, that is called simple additive weighting, and to improvise the other methods followed with SA, that is called simple additive weighting, like AHP, used to call it as the analytical hierarchy process. And then TOPSIS, currently I'm dealing this one now, that is called technique for order preference for similarity to the ideal solution. And then there are various techniques available. It is not only the MCDM techniques which are available in front of us, like ANP, Electri. There are techniques which is TOPSIS, Prometheus, and there are many other methods also available. But for the sake of the PPT, I just kept it here like this, because when you implement something called TOPSIS, you must understood something about AHP and the SA, because SA and AHP are very basic MCDM approaches. The SA was improvised, then the AHP has introduced, and then AHP was further improvised, then the topic called TOPSIS comes, right? So therefore the TOPSIS is for today's session, and I'm not dealing the ANP and Electri, because these are very complicated, and a simple basic problem is not sufficient to explain this ANP and Electri. Those are complicated things. But yes, TOPSIS will bring the basics of the ANP and the Electri. Why I have chosen only the TOPSIS now? Why I have not chosen the AHP, SA, or the other methods? The reason behind that is, if you see the recent publications, that is at the 2019, right from we have taken this analysis from the sciencedirect.com only for the implementation of TOPSIS of various models. So from 2014 to 2019, the publications who are using this TOPSIS was rapidly increasing. So you can find from this histograph. From the histogram, you can see that 986 publications at 2019. Yes, MCDM approaches are now gaining its importance, and out of that, the TOPSIS is widely used. Why the TOPSIS is widely used? Because of its simplicity, first of all, and it will give the effective solutions while solving the problem. That is the reason behind it. So it was first introduced by Wang and Yoon at the year 1981. And the basic concept of that is, to identify a compromise solutions. So what is the meaning of compromise solution here? Anybody in the participant can give an answer for this. The concept of compromise solution. What is a compromise solution? Yes. Can I get the answer from anyone? Yeah, but Dr. Warren, are you there? Somebody,
Yeah, muted.
yeah, okay. So, participants, could you get my question here? Are you with me, right? Okay. So, the meaning of, let me tell you then, what is a compromise solution? The meaning of compromise solution is when I said you an example, car example, right? Somebody is looking for car, and somebody perspective maybe minimization of the cost is a priority, and somebody maybe the quality might be the priority. The cost is basically what you do. You have to as minimum as possible is good for the someone. And when you talk about the quality is as maximum as possible. That could be good for that particular that particular individual. When you talk about minimization and maximization and how to achieve a common solution out of it, of course, that would be a wonderful solution. If you said that yes, cost is as minimum as possible, and the quality is as maximum as possible. If certain individual, if you say that this particular car is having low cost and high quality, obviously I will take that particular car, right? So when you bring this kind of solution, which can be satisfied for everyone, that kind of solution is called compromising solutions. How to achieve this compromising solution? I said you, there are many these kind of solutions or this kind of problems is called multi-objective problems. So identifying a solution or the best solution for this kind of multi-objective problems is quite complicated. So that kind of problems can be, that kind of solutions, compromises solutions can be achieved with the help of TOPSIS. That is called compromise solution concept. And out of these compromise solutions, you have to choose how to find from the TOPSIS, you have to find the best alternative nearest to the positive ideal solutions. I will detail you what is called positive ideal solution and the negative ideal solutions. Generally, positive ideal solution in the TOPSIS, we are calling it as best attribute. A negative ideal solution, we are calling it as a worst attribute. If it is a maximization problem, the best, if the solution moving towards the positive is called best attribute, and the solution is moving towards the negative ideal solution is called worst attribute. When a problem is minimization, and when the solution is going towards the negative, is a best ideal solution. And if the solution going negative, it's called no, it's not a best. So in that way, the best positive ideal solution, the negative ideal solution is defined. And to achieve a compromise solution, we will do a minimum Euclidean distance method, and that will leads towards the final optimal solutions. So this is about the TOPSIS now. And the methodology we will follow with respect to TOPSIS is like this. First, you have to define the criteria and the alternatives. See, I'm using the language now called MCDA, multi-criteria decision making analysis. So here, something called criteria and something called alternatives. So I will, with the help of an example, I will let you know what is called criteria and what is the alternatives. At present, you understand the criteria may be a parameter, and the alternatives are the sub-parameters. If you improvise these sub-parameters, it will the parameter will also improve. Up to now, you think in that way. When the problem description will come, I will explain you what is called criteria and the alternatives. With the help of this criteria and the alternatives, first what you do is you will formulate a matrix. And after formulation of the matrix, what you do is you will normalize it. So anybody here can give an answer about why you are doing normalization first. I'm not asking very big questions here. It is general mathematics. After you find the values, why you do normalization? Anybody?
Okay, yeah. So maybe because we have all the values not in the same range. So some may be in one, two, and some may be in thousands and hundreds. So by normalizing, you can bring everything under one scale.
Exactly right. Yeah, that is what that is a reason why we do the normalizations. Maybe I said you the cost and quality. Cost is generally defined with 10%, 20%, 30%. Sorry, the cost is defined with the values like 100, 200, 300, maybe 1,000, something like that. But if I ask you about the quality, you can define with the percentages like 20 percentage, 30 percentage, 90 percentage, something like that. So here the values are ranging from 0 to 100 percentage, whereas the other values are ranging between 0 to thousands. To bring the common scale between these two, not only these two, if any of the parameter, their ranges are different. To bring the common scale between these parameters, you will do normalizations. That is why we are doing normalization next. And then we will use the weighted normalized matrix. After defining it, maybe the perspective of the quality may be high for one individual. So for that, we have to give the higher preference rather than the other parameters. To give the higher priority and the lower priority, this weighted normal matrix may be helpful for us. Now, and then you will find a positive and the negative ideal solutions. Then you will find a closeness coefficient between the positive and the negative to define the rankings of the alternatives. Now, this is the methodology we will follow. That methodology I explained here in this step-by-step process. For explaining, for example, I said you first define your alternatives, that is alternatives and attributes. After defining it, you have to generate a matrix. That matrix I have taken as I is an option and respect to criteria J. The matrix is defined by M by N depending upon the attributes and the criteria. And then you have to find the benefit of the attributes. More is better or less is better. I define the values as J star and J hyphen here dash. J star represents it's the more is the better. J dash indicates it's a negative attribute or the criteria which is less better. So this is the terminology I will use further. J star and J dash and Xij, where I and J is called option score or the criteria. Very first step, what you do is, after defining your matrix, I said you have to normalize it. So how you will normalize in general? This is the formula we will use for the normalizations. That is Rij is equal to what are the value you are having with you, that divided by square root of summation of all the values with respect to column or the row, right? It depends upon it. So if you do like this, this is the formula for normalization. And then in the second step, you will see the weightages. Now, Rij represents you normalize the values. For those normalized values, you will define the weightage. Weightages generally depends upon the priority. If my priority is higher for those parameters, I will give the highest value. Generally, these weightages will be defined in the range of 0 to 1. That is 0.2, 0.3, 0.5, something like that. Okay? 50% of my priority to this, 20% of my priority to this, or 65% of my priority to this. Like that, all the parameters will be defined with respect to their weightages. So that is about the weighted normal decision matrix, and then you will find out the positive ideal solution and the negative ideal solution. The positive ideal solution I will represent with A star, and the negative ideal solution I will represent with the A dash, where A star will get the value which is maximum if J belongs to J star, and a minimum J dash. This is the representation, and the negative ideal solution, its minimum is the best. The minimum is the best, that is represented with J star, and maximum is not the best. That is why we are doing J dash. This is the representation of the positive ideal solution and the negative ideal solutions. And then I will calculate the Euclidean distance after identifying the A star and the A dash. Right? After getting the positive ideal solution and the negative ideal solutions, with the help of those, I will calculate the Euclidean distance. So let me ask you a question here, why we are using the Euclidean distance? And before that, let me tell you in brief, where the SAW method and the AHP, which I used in the initial slides, they use the simple average method and simple weighted methods. But this Euclidean distance is using in the TOPSIS, which is helpful for us to leading towards the optimal solutions. What is the beauty of this Euclidean distance? Any answers from the participants? Okay, fine. Okay, fine. I will explain you anyway how this Euclidean distance is helpful to achieve the optimal. So, for example, now I am taking a criterion. This is the criterion 1 and criterion 2. The meaning of criteria 1 and criteria 2 is called two different solutions I am looking for. And we know this is the solution space, right? This is the solution space where number of solutions I got it here. Solution 1, solution 2, solution 3, 4, 5, 6, 7, 8, 9. In general, all these solutions, what we are calling according to operations research is called feasible solutions. The meaning of feasible solutions is any solution is fine. Any solution is in this feasible region is can be a solution. But out of these feasible solutions, we have to identify a solution which is optimal, right? So to identify the optimal solutions, first you have to find out. Let me take one alternative. So I selected this is one alternative that is called A1, and another alternative. Let me randomly choose. I chosen this one, A2. Now what I do is I will find out out from these alternatives the distance between positive ideal solutions and the negative ideal solutions. I said A star is called a positive ideal solution and A dash is called negative ideal solutions. First I will identify A star and A dash, and then I will identify from this A1, for example, if you take the alternative A1, I will calculate the distance of A1 to A star and A1 to A dash. Depending upon that, I will select whether A1 is positive ideal solution or the negative ideal solution. That is J dash and J. This is what I said A star and A dash is called positive and ideal solutions. After identifying out those, your alternative falls under which one? With the help of this Euclidean distance, right, I will identify whether this solution is better or this solution is better. With the help of those Euclidean distance. It is far from this A star, which indicates it is negatively ideal solutions, which is not better. If A2 is having the less distance than A1, then A2 is better than the A1. This is about the Euclidean distance, as simple as it is, right? So now, what I do is, after identifying of this, so I need a common ideal solution out of all the solutions. Therefore, I will do the closeness, relative closeness. This is for after identifying the positive ideal and the negative ideal solutions. I will do the closeness ratings that divided by this one, and of course that should be ranging between the zeros and ones. So this is the steps we will follow while solving the topics. Up to now, whatever you saw is a mathematical formulations, the representations of different steps involved in the topics. Of course, some of you are not happy or you look complicated by seeing all this. But let me make it very simple. For that, what I do is I have taken one example. As the participants are interdisciplinary and they are of different specializations, I have taken this common example for everyone. That is a mobile. So here a mobile phone selection here. For example, this is the attributes. The attributes here is mobile phone is an attribute. The criteria here is price or cost, storage space, camera, and looks. These are called as criteria. and these are called mobile phone is an attribute. So now, according to the first step, I should have to have attributes and the criteria. Yes, I'm having attributes and I'm having a criteria. And in the meantime, I also taken the weightages of this. Here for this example, I have taken the equal weightages. If you add all these weightages, it's supposed to be 1, right? Generally, the weightages are ranging between 0 to 1. So I have given the common weightages, that means 25%, 25%, 25%, and 25%, like that I have given this. So now what I supposed to do is find the ranking preferences for 5 mobiles to find the best mobile among the 5 mobile phones using the top list method. So now with this data, let me ask you a question. Which mobile phone is the best mobile phone?
Mobile number 2.
Somebody said mobile number 2. Yes. Any other answers? Any other answers? Okay. Okay, let us see. Let us see. While solving the problem, you are taking care of all this price, space, camera, looks, all into consideration, and you need to identify a solution like out of this mobile 1, 2, 3, 4, 5. After solving the tops is what you will get is I will arrange these mobile phones into according to their rankings by considering this all these criteria. That is 1, 2, 3, 4, rank 5, total 5 mobile phones. That is why I will give 5 top rankings. Out of that, the first one is the best one. The next choice is second, next choice is 3, next choice is 4, like that. Right? Let me take this simple example. Let us solve it. The very first step is, yes, I have all the attributes and the criteria. Now, calculate, for each column and divide by each column to get this is called normalization, right? For the normalization, what I do is, for example, I am having 250 here, 200, 300, 275, and 220. So according to this form,
Hello. Hello. Vijay, your voice is gone now. Okay. It's breaking.
it's breaking.
Hmm.
1 second.
Up to this time, it was okay.
Okay. Unstable. The connection is unstable. 1 second.
Okay.
Okay. Can you hear me now? Can you hear me?
Yeah. Now it's fine. Okay.
So, what I do is, I will do the normalization for this particular matrix. How to do the normalization is 250 square plus 200 square plus 300 square plus 275 square plus 225 square. After doing that, I will apply the square root of this is 1 by 2, square root of this. So I applied the square root of all this. I got the value 464.5 something. So that value is there. So of this normalized value, I will divide with each parameter. 250 divided by that normalized value. 200 divided by so 300 divided by what are the value I got it here. That becomes Rij, right? And here also 16 square plus 16 square plus 32 square plus 32 square plus 16 square and square root of all that. I'll get the value that is called 553.0658. That value I will divide it by each attribute in the storage space. Similarly, I have done for the camera. Similarly, I have done for this. This is how to do the normalizations. After do the normalization, I got the value. That's for normalization. Through this normalized value, what is the next step is multiply each column by weightage. What is the weightage of price? I set to 25%. That is by 0.25. Similarly, for the storage space, we have taken the weightage as 0.25. That is why I multiplied with 0.25. Similarly for the camera, similarly for the looks. That is why I am multiplied with 0.25. So after multiply with each and every attribute, with each and every criteria, with those weightages, I will get the weight. This is the table I got it. Among this table, next what you're supposed to do is determine positive ideal solution. We are representing the positive ideal solution is A star. How to find the positive ideal solution from this? See, let us see this column that is called price. I sent you positive ideal solutions. That means the solution which is having, the value which is far from it. For example, price. Let us take this one, 0.1, 0.08, right? And this is the value we got, 0.12, 0.12, and this is the other value. So out of these, the value which is very less, because the price indicates the price is, for the price, the cost is less or high. For the price, the price should be less. Therefore, the value which is less is positive ideal solution here. That is why the most least value I have selected, 0.086. That is why I represented as this one. For example, storage space. The storage space should be, high or less. Storage space, yeah, that is why. The positive ideal solution is 0.158. The highest value I have taken. Similarly, for the camera. For the camera, the resolution should be high or less. Obviously, it should be high. Therefore, the positive ideal solution A star is supposed to be 0.12. That is why the highest value you have chosen. And one should be careful. Sometimes you will get the equal values. And don't worry about it. Highlight those equal values. Take that value, right? And looks. And look should be, of course, it should be good. It should be maximum. So that is why I have taken the positive one, which is highest value, that is 1.4. Now I identified all the positive ideal solutions and I represented with the value called A star. And these are the positive ideal solutions. Similarly, I have to identify the negative ideal solutions. That means the reverse of it. Here, the less value is this one, right? So therefore, the price is should not be very high, but I have chosen this one. The meaning of this is called, it is a negative ideal solution. Similarly, all the negative ideal solutions I have represented, and I am representing that particular variable as A dash. And this is the negative ideal solutions I got it. Now you got the positive ideal solutions and the negative ideal solutions among all the feasible solutions in your feasible region. So after that, what you're supposed to do, according to you have to identify the Euclidean distance. That means the distance between V star minus Vij according to the positive ideal solutions. But according to the positive ideal solutions, the Euclidean distance is represented as S1 dash. Now you have to take the positive ideal solution. For example, let me take the mobile number one. In the mobile number one, let us go back to the positive ideal solutions. Mobile number one, this is the value, right? And the positive ideal solution is 0.086. Therefore, the Euclidean distance is 0.0 minus of that and whole square. And next value, that is 0.0754. Where is 0.077? This one. Minus of this particular value. Based on this one. Minus of this one. Minus of this, right? Like that. For the negative values, similarly, this one minus of this, A dash, 0.075 minus of this particular value. What you call it, that is called A dash. In that way, the positive ideal solutions, here for the positive ideal solutions, to do that one, on average, we got the value that is by 0.0074. Right? And that value, you will get it here. This is the value, that is sigma of summation of Vj dash minus Bij whole square. And I done the square root of it and got the value Si dash. Similarly, for the all mobile 2, mobile 3, mobile 4, mobile 5, I got the values which are the Euclidean distance values for the positive ideal solutions. Similarly, you have to do for the Euclidean distance for the negative ideal solutions also in the same fashion. We have done and we identified S1 star and the S1 dash now. With the help of these two values, you have to identify the relative closeness. How to do the relative closeness is, that means Si dash divided by Si star plus Si dash. With the help of that, you will get the relative closeness values. Now we got the relative closeness values. With this relative closeness value, you will find out, you will identify the value which is having the highest. For example, in this, which value is having the highest here? Ci dash, that is relative closeness value.
Mobile 3.
Mobile number 3. The weightage what we got here, relative closeness is 0.69. And the next best is like
0.5353.
0.5348. 5348 and 5342. Right? So mobile number 4. Let me, accordingly, I have arranged these nicely. Now, after considering this, all the attributes and criteria, I can go ahead. I can say that, yes, mobile number 3 is the best choice. And if you choose this mobile number 3, you can pay less cost. You will get the high quality with respect to those parameters. You will get the high pixel, right? So therefore, my choice after applying of the tops is that mobile 3 will be the best one. And then the mobile number 4, and then mobile number 3, sorry, mobile number 1, and then mobile number 5, and then the mobile number. When I was asking somebody, said the mobile 2 is the best. If you choose that, definitely you will lose money. You won't get the best mobile phone out of these 5 mobile phones. So for this, the tops is AHP or whatever the methods in the MCDM will help us to identify these rankings. Right? I hope most of you got this. What is this MCDM? What are the topics looks like? And now I would like to take one another example. I will quickly go through it and how this particular example can also implemented in the manufacturing problem. So every one of you here who are at least working in the mechanical engineering can definitely identify by seeing these attributes and the criteria that, you know, titanium is the best choice for the aerospace applications. Here I have chosen, find the ranking preference of 4 materials to find the best material for the aerospace application among the 4 materials, right? So definitely I can also say that titanium is the best one, right? So these are the weightages. For the price and cost, 0.1, density. Now what I done is, the weightages preferences, I have changed it. Maybe because that particular, when I choose the material, the density should be very high. I should not compromise on the density. The density is should be very high compared to my cost. That is why if I choose these two, the density should be high. That is why I have given highest preference to the density. The next highest preference I have given to the weightage, and the next highest to the strength, and then the next highest to the price and quality. So, but if you make it equal, it's supposed to be 1. Because ultimately the value should be 1. It should not be more than 100%. That is, in that way I have chosen the weightages. And this is the attribute criteria matrix, I got it. And after applying the topses, like you know, the very first one is identifying, you have to make it into a common scale, because previously it is looking like this. I have applied a common scale. I normalized it by applying the formula what I said to you in the previous example. And then after multiplying with the weightages, I got this matrix, and then I identified a positive ideal solutions, which I have marked it with the blue ink in color. This is the positive ideal solutions. And also I need to identify the negative ideal solutions, the quite reverse of it. And then I have to find out the Euclidean distance for the positive ideal solution as well as for the negative ideal solutions. And then I have to identify the closeness. Out of the closeness, you know, No, these are the closeness values. Which one is the best choice for these materials? For the aerospace applications, definitely I will go, but titanium is the best one. The next preference could be like cast iron. The next preference could be the aluminum, and then the least preference could be the stainless steel. To identify these kind of problems, you will apply the topses, and it will give this kind of rankings, right? So fine. Up to here, I'll just stop for a minute because I would like to know, is it clear for everyone? If you are having any queries with respect to this, please let me know.
Participants, you can unmute and you can share your queries, or if you want to have any discussion.
Excuse me, sir.
Yes, please.
Yes, sir.
Sir, in the case studies too, as per your presentation, the aluminum will be the optimum, sir.
No,
I don't know. Because in the point of density, if density increase, automatically that weight also will be increasing, sir. And that fuel in terms of fuel, that cost, everything will be plays a major role in this part. I don't know exactly when
okay.
it is.
Okay, let me give you answer for your query, sir.
Yes, sir.
Here, what we have taken is, first you have to identify what preferences we have taken for this problem. Here my parameters are with respect to price, density, weight, and strength. When you said something about some other parameter, like you were saying with respect to fuel cost, or with respect to something other parameters, of course I will add those parameters here. Then accordingly I have to find out. One such limitation for TOPSIS is, if you remove any parameter or if you want to add any parameter, you have to redo your MCDM method again. And then according to those preferences, maybe the rankings may be different. According to these preferences, that is price or cost, density, weight, and strength, this is the best choice. Titanium is the best choice.
Oh, we need to integrate all the parameters, and
yes.
then only we can. Oh, yes,
Yeah.
yes. Now I can understand, sir. Thank you.
Okay.
Thank you.
Okay. Any other queries from the participant side? Because next I am planning to move to use cases. Okay, then can I carry with the use cases now? Here in the participants, anybody is working on the area of supply chain? Anyone working in the area of supply chain management? No one. Okay.
Maybe no one.
Okay. Fine. This is the problem when we deal with the course in virtual mode. We cannot identify the status of the participants. Yeah, fine. No, not an issue. Let me show an example with respect to supply chain management area, which we published along with my students. This is the area. This is the topic. And, this is the title. You can copy and paste. If somebody interested to see in detail about this particular use case, you can download this paper. It was published in one of the international journals. It's called Selection of Green Suppliers based on GSCM practices, that is called Green Supply Chain Management Practices, using fuzzy MCDM approach in an Indian electronics company. The case study what we have taken is called Indian Electronics Company in the India, among the electronics companies who are following the green suppliers. The meaning of green suppliers here are those who are following, triple bottom line aspects, sustainability parameters, like your so-and-so component should be economical, ecological, and socially, it should not be harmful to the society. It should not be harmful. Such a practices need to be done by any organization, not only electronics company. In fact, any company should do the same thing. So here, with respect to Indian electronics companies, among the top 10 in India, those we have taken in such a way that they are following also the sustainability norms. Those are green suppliers. And among those green electronics companies, we have chosen, by applying this TOPSIS method, we have chosen which one is first and second rank. Like in ranking order, what we have done for the TOPSIS in the last two cases, we arranged in that order, so that you can see, it's a number one supplier, number two supplier, and number three supplier who are following the green supply norms according to the Indian standards, right? So that we have done here. Of course, I brought something called fuzzy here. Don't confuse with the fuzzy. Fuzzy is something like, if you generally, the variables in the real life environment may not be zeros or ones, or yes or no. It might be something like maybe, could be, yes, it could be slightly differ, it could be strongly differ, something like that. So to define these kind of parameters, you cannot represent with the zeros and ones. You should be represent with some other values, like 0.5, 0.2, 0.1, or something like that. To define these particular variables, we incorporated something called fuzzy. The fuzzy will be helpful for you. That is the only essence of fuzzy, right? So other than that, the methodology, what we have solved with the simple examples in the previous slides, the same thing we have used here. But yes, as a research problem, the variables or the attributes, the criteria and the sub-criterions are too many here. That is the only difference. And therefore, you cannot solve with the help of hand. You have to use something called software, or you have to do some program. But the logic is same. So now, this is the case study I have taken. This case study has been taken from the electronics industry. In this electronics industry, almost 600 employees are working in a shift basis. In any shift means here they are using 3 shifts. Shift 1, shift 2, shift 3. Each shift consists of 8 hours according to the Indian norms, or in fact in the global norms. And the major role of this company is, they assemble electronics products, generators, inverters, etc. And what they want to do is, they have to do some alterations by product lightweight. The product should be lightweight. The product should be recyclable. The product should not emit any toxic chemicals, or significantly, there should be low consumption of electricity. Because why company shifted to this route is because of recent sustainability norms implemented by the Indian government. That is why they have to go for sustainability parameters. For that, the sustainability manager of this company needs to find and choose the suppliers. Therefore, they have to choose the suppliers who are following this green supply chain management norms or the practices. So how to do that? How to identify among the green supply chain practices, which one will be the best one so that the company can achieve this kind of thing, that is lightweight, recyclable, toxic, etc., etc. So that is a company. Here we have chosen 10 potential suppliers for doing this. These 10 potential suppliers have to follow all these norms. GSEM1, GSEM2, these are the criterions. They have to follow something called ISO 14001 certification. If somebody is following this certification, means yes, they are following the GSEM norms. According to Indian standards, they are following the sustainability norms. Like for example, let me take GSEM 12. The meaning of here, company acquires cleanest technologies. What are the technology they are using? It should be cleanest. That should not be harmful to the any environment, right? Like that, we have taken all these parameters, and then among these parameters, the companies what we have chosen, the 10 companies, we applied the methodology called TOPSIS or the fuzzy TOPSIS. We got the rankings like this, which means A10 company A10 company is the best company which is following all these norms. Among the 10 electronics Indian companies, I'm not revealing that, it's a clear case study. Among the best 10 companies which followed all these norms, and we identified if you want to, if the supplier want, if this particular company, if they want a company which is the best out of this 10 potential suppliers, means they will choose A. They will choose A10, and then they will choose A3, and then they will choose A5, and then the next company they will choose is A4. Like that, they will choose. Like that, they will choose the best, companies out there. So for that, the TOPSIS will be helpful, and for GHP, TOPSIS will be helpful, right? Any queries up to here? Participants is having any queries with respect to this, you can ask them. Okay, I would like to take another example. This paper is recently published actually. Our participants are with me, first of all. Can I carry on?
Yes, sir. Go ahead, sir. We are here.
Okay.
Sir, one more doubt, sir. Sir, to carry out this fuzzy TOPSIS, what software we need to use, sir?
Sir, simple Excel we have used it. For this, there is no software. Simple Excel is quite sufficient for solving this kind of problems.
Okay, sir. Okay, sir.
Yes. Let me give you one more example, which we recently published in International Journal of Cleaner Production, which is the prestigious journal with impact factor 7.3. And these small methods can do a magic and can give you a very good optimal solutions for very complicated problems. Let me show you that example. This was just accepted and it will be published in the International Journal of Cleaner Production maybe in a week of time now. Here, every one of you, the current context is everyone is suffering for COVID-19, right? For that, you are aware that COVID-19 is a pandemic. Everyone is suffering it. When you go to the hospital, nobody will entertain to go to the hospital now at this current stage. If you are getting a fever or cold or something else, even you are diagnosing that in your home itself. You don't dare to go to the hospital. But we are taking the other context. That is, after treating of the patients, how these different waste, that is called a cotton or syringe or something like these equipments, is disposing. And while they were disposing it, are they disposing correctly? What are the techniques they have used for disposing? And which disposing technique is best one to do it? And in Indian context, whether they are doing it correctly or not. That is what we have done here. That is called selection of best healthcare waste disposal techniques during and post-COVID-19 pandemic era. That is what we have done along with my students and Professor Kumar from IIM Raipur and some of my BTech students. Here, we identified a best technique, but unfortunately, let me tell you the reviewer question here. The technique what India was adopting is not suitable according to the COVID-19 era. So because the current best practice what we identified from the result is not the best one. If you do that one, you will suffer a huge in the later years. But there is no other go for us. Anyway, we have to do that. Another best choice or the best method we have to go through. Otherwise, we will suffer definitely in the later years. So let me show you that particular problem description here. You know very well about COVID-19. The countries are affecting a lot. Of course, in India also we affected a lot. Out of that, states like Maharashtra, states like Delhi, states like Chennai is badly affected among the other states. So after doing this analysis, what we done is we have taken the data from one of the mostly affected region, that is Tamil Nadu. In the Tamil Nadu, the state like, Vellore, you can find a very prestigious hospital called CMC, Christian Medical College, where it is very famous for the cancer patients, diagnosing of the cancer. So there we have collected the data, and we identified the best practice, the best of the best practice they are doing anyway, and how they are doing, what they are doing, that we have identified, and that is presented. That is a case study we have. And these are the healthcare waste treatment techniques available in the entire world. One could be incineration and cremation, integrated steam sterilization, plasma paralysis, chemical disinfection, microwave, autoclaves and retorts, encapsulation, and landfill. These are the healthcare waste treatment techniques which are available in the entire world. And factors affecting HCW treatment techniques are, we have chosen because we have to follow triple bottom line aspects, which is social, economic, environmental, and technical should be good. For that, for the social, public accessibility, operational safety. When you talk about something like healthcare waste techniques, I said you attributes and criteria we have to identify. If you are following these social, environmental, economical, and technical is called attributes, you have to identify the criteria with respect to the attributes. Public accessibility and operational safety is for social. Environmental, you can use toxic emissions and health effects, and waste residuals comes under the perspective of environmental considerations. And annual operating cost, infrastructure requirements, HR, human resource requirement comes under economic conditions. And in the technical, treatment efficiency, reliability, and treatment system capacity comes under the technical. So these are the various factors which are affecting the HCW treatment techniques. And then we adopted a methodology for that analysis of the data. Depending upon, we have taken the questionnaire and the responses from the 6 decision makers. We adopted the method called fuzzy VCOR and the fuzzy topsis. VCOR is the another MCDM method. Here you use the fuzzy topsis. I said you why we used fuzzy, because the decisions are not zeros and ones. It could be mixed ones. And after, these are the criterions we have taken, different criterions. Annual operating cost, public accessibility, all this, and the brief description we have given here. These are the alternatives. That is 9 techniques, right? These are the 9 techniques. 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the 9 alternatives, and these are the criterions. So, which one will be the better one? Which method will be the better among these criterions? These are the criterions according to the Indian context. If you go to Europe, the criterions may be different. If you go to the country like European standards are different and Indian standards are different. India is following the criteria called Kyoto protocols, right? Which is Japan and Asian countries are using, and European criterions are entirely different. Their criterions may be different. According to the Kyoto protocol and Indian and Asian conditions, we have used, these are the criterions, and these are the alternatives. Landfill can be used, because most of the private hospitals nowadays, they are doing the landfill, which is very dangerous. And while doing the landfill, if you see some hospitals nearby, the pigs or the dogs used to touch that waste, and then it is spread to the smallest rack pickers and their children over there. From there again, it will spread to human, and next is you can find the disaster. That is landfill. It is it should not do actually, right? So every method is having its own procedure. I'm not going into the details of these procedures, but out of all this, after applying of fuzzy topsis, what we find from that hospital is the incineration is the best process. Yes, even among all the processes, we identified incineration. The meaning of incineration is they are just burn it. After they take out the needle from your flesh, they will take it out and they will just put it in a hot oven. There, the syringes or whatever the waste you put, they will burn it. That kind of procedure is called incineration. Anyway, that we are following right now, and that is the best. That comes under the first category. And the second category is integrated system sterilization system. And the third alternative, what we got, according to the procedures, what we are following, is called microwave, all this. And according to the other methods also, we almost got the rankings, because this is just a comparison study. Incineration is the best one. So of course, they are also following the incineration. But whether the incineration is the best process to do it, according to the pandemic, for the pandemic, we have to follow the other conditions, other methodologies, which are what we are not doing, which are not adopting from the Western countries, but we have to do. So that is what the difficulty we got, even after identifying the results. We got the difficulty for publishing because it is a cleaner production journal. They said, for the cleaner production, this is not a clean incineration. What are the results you got it? Then we found that India is following incineration and it should not be followed. There is the other methods we should, that kind of statements we have to. So that is what my presentation is here. I have detailed with the healthcare systems perspective. I detailed with the supply chain perspective, and some manufacturing problems also I have taken, and supplier selection and normal problems also we have taken. And this kind of methodologies we can adopt to number of problems. For example, for these sessions might be some of you explained about manufacturing and related problems, this Taguchi or gray relation analysis. Ultimately, what you are getting the weightages that can be integrated with the TOPSIS for finding out the most effective solutions. So, DOE can be integrated with the MCDM, or MCDM can be integrated with the DCM to find out the most effective and efficient solutions. And further, that leads towards most global optimal solutions. So that is about my presentation. If anybody is having doubts, that you can raise it.
Yes, sir. So anyone has any kind of queries, please unmute and ask. Okay, in the meantime, I'll ask, sir, in this, when we are comparing this multi-decision making, we have so many different methods, but how do we know that first our model itself is right? Because what you have explained is all about the decision making, but do we have any concern on the models as well, or do we need to make sure that our model is right, and then we can proceed?
Yeah, exactly. Very, very nice question here. So what I have not shown is after you got the result. After you got the result, whether it is right or wrong, whether the matrix what you initially have taken is right or wrong, could be do with the help of a consistency index or critical index. There is there you will find out the a systematic way to validate your model. There we have taken the eigenvalues and the eigenmetrics method. There is a method is available after doing these rankings. With that methodology, if your consistency ratio is below 0.1 or something like that, then you will find that yes, the matrix what you have taken initially or the model what you have generated is right. You have to do that procedure. That is there anyway in the MCDM.
Okay, that is there in the MCD, but will it address the data that we have taken? Like, will it address only the model, or will it address even the data? Suppose there are any errors or outliers or miscellaneously some error might also be incorporated in the data. So how can we address that?
Yes, that is why we are taking, yeah, this is another nice question. Actually, while taking the data, you are taking from the different decision makers. It is
Right.
not one choice. And the different decision makers, while they are giving their respondents, we are giving the separate scale. At least there are many scales available. Out of that, 9-pointer scale is called Sati scale. Uh, it's the scale should be prefixed or predefined while you are giving the questionnaire to the decision maker, so that he will confine with that scale. If somebody following other scale, it's not 9-pointer scale. If they follow 5-pointer scale, the values what you will get is according to the 5-pointer.
Okay.
So there is an inconsistency of data. Then you will generate inconsistent data. So this inconsistency you have to take care while you are predefining your scales. So
Oh,
therefore, all the decision makers will at least follow that particular scale. In that way, some kind of inconsistency you can avoid by defining the scale. And even though you gave the scale, different respondents will give you different answers.
right.
After that, what you generally do is your respondents or the decision makers should be a huge in number, at least. Like in general, according to the qualitative analysis, 35% of the data is required out of 100%. That means if you give the 100 respondents, at least 35 respondents should be required to generate the data first.
Okay.
This is the criteria we are taking for avoiding these inconsistencies. So that on an average, if you take it, then this inconsistency already you will be eliminated.
Okay.
These are various methods and the various ways to avoid the inconsistency.
Okay. Yeah. So we get these inconsistencies in while taking any experimentation. So that's what was my question. So thank you. Any other participant wants to ask any other query?
Sir.
Yes, sir.
Yes.
Sir, this question is very, very general. Sir, not related to Topsys or any other method. Sir, before going ahead with this Topsys or something other, as Dr. Varun asked, still we are not sure about whether our model is, whether design is correct or not. How we can identify easily, sir, in general?
Sir, for example, okay, I'm not going with respect to the Topsys. Let me go in general. After you solve the so and so problem, after you define your problem description, whether the problem description and the values what you are taking is right or wrong, whether I can go ahead with that problem description, whether it is quite sufficient or not, right?
Yes, sir.
Uh, how to validate this kind of models is in general, if it is a mathematical oriented problems, of course, for the problem description, you might be having certain mathematical model with you, right? This mathematical model, you first define a small values, a small problem, you first solve it. When you solve this particular small problem with the less values, or with hand, generally you can do with the help of numerical small example. Then there itself you can see that yes, I'm getting some vague value other than the fixed value what we are getting. Let me take you one simple example, like operation research problem. One simplex method you have to adopt. So with the help of the simplex method also you can solve the problem, and if the problem complexity is very high, you will adopt something called branch and mount method, all the evolutionary algorithms. Take a problem, take a mathematical model with less constraints, or with the help of one constraint, try to test that one with the help of your hand calculations. That is one method to do it. If your calculations is not giving the better, then there itself you will eliminate, or you will your mathematical model you will redo. That is one way to do it. The other way to do it with the help of the qualitative analysis is you have to generate lot of the data, after generating of the lot of data, the consistency should be proved with the help of methodologies like validation. Do some validation. If you are doing some validation, your results is not so much of close to that particular models, then obviously your model is something wrong. How to test and try with whether your model is right or wrong is called sensitivity analysis. Take one parameter. Out of many parameters, take one parameter and keep on increasing or decreasing the values with plus 20% or minus 20%. When you are increasing with the 5, 10, 15, 20, 25, 30, obviously your values, for example, if your problem is maximization case, the value should be increasing in order. Similarly, you have to do for the negative values also. For the same parameter, try to test with the negative side, minus 5, minus 10, minus 15, minus 20, and your value should be in a decreasing order. If something is wrong, if something happening wrong, it is your values is not increasing and not decreasing, even though your parameters are, when you are doing the sensitivity with increasing those values, then definitely there is something wrong in your problem description itself. In this way, the sensitivity analysis is one such way to do it. The other one is rude method, that is hand calculation. These are the different ways that you can examine that whether your parameters or your data or your model is right or not. I hope at least I can give some sense of your question. Not totally, I can say.
Yes, sir. Thank you very much, sir. Yes, Sandeep sir yesterday has given some information. The same information you are saying, sir. I think this will be optimal. Thank you, sir. Thank you very much.
Okay, okay, sir.
Yes, sir. Venkatesh, sir, you want to say something? Your audio is not clear. There is scrambled noise. You may also type in the chat window if the question, what you are asking, you can type in the chat window so that I can read it out for. No, not at all audible, sir. You may type in the chat window. Totally scrambled. Nothing is audible, sir. Only I can see the mic, showing some noise. So I'm assuming that you are trying to say something. Fine. Okay.
Otherwise, Varun, take the query. Definitely, I will reply back in some time.
Sure, I'll do that. I think you may either use WhatsApp and you can message me later also. I'll forward the same to Vijay so that he'll get back to you with the relevant answer. All right. So if nothing is there, so okay. Okay, so we'll come to the end of the session, and I would like to thank Dr. Vijay for accepting the request. And he is actually busy with so many SCTPs already planned, and FDPs are going on. So in spite of this busy schedule, he has accepted. And then with case studies, it was very clear, and TOPSIS and today morning gray relation analysis, it all fit well. Actually, many of the participants are new and they are in the beginning, I suppose, and that's maybe the reason why they are struggling to correlate these things. But once they look into the research papers and once they start writing the articles and all, and when they realize that they need to make a decision on multiple criteria, maximum and minimum, and that is where these models will help a lot. And I think these techniques will help them in making a better decision. And like you said rightly, the case studies that they build, they should validate rightly. And once they do those validations, sensitivity tests and all, they will have a better publication chances. And it's a clear case studies where you have shown both the way reviewers will accept and the way reviewers may reversely question us how it is possible for that particular journal description. So I think that is a really nice thing to understand, and for the young researchers, these things are needed. I thank once again Dr. Vijay for accepting and giving a wonderful talk. After a long time having a talk with you, it's very nice to once again have you here. Thank you.
Thank you, Varun. Thank you. It's a great opportunity for me in this particular platform. Thank you so much.
Thank you. Participants, I'll share the feedback link in the WhatsApp group. And if you have any other queries also, you may message in the WhatsApp window. I will share with Dr. Vijay and we'll get back to you. So thank you, everyone. I will end the session now. Thank you, Vijay. Thank you once again. Bye.